Hello again, my mathematicians. So today we're going to be continuing with section 3. So again, note taking section 3, which is still on exponential functions. And I want to start off by reviewing what we did at the end of the last video. At the end of the last video, we saw that an exponential function has a form that will always look like f of x equals ab to the x. And we had said that the value of b is always that factor or multiplier that we explored in the previous video. And we had said that the a value is the y value of the y-intercept. Keeping in mind that the y-intercept is an ordered pair. That's why we call it the y value and not just the y-intercept. So it's got to be of the point 0, comma, a, okay, whatever that a value is. And those will always be true. We had done an example making a table using this form. So I hope everybody feels comfortable with this idea that this is always going to be true for an exponential function. So we learned about how the factor size will tell you if you have growth or decay. So let's put that fact in. If the factor is a decimal or a fraction, or in other words, between 0 and 1, we know that we have exponential decay because we're only taking a fraction of the previous amount every time. And we know that if the factor is greater than 1, then that tells us we have exponential growth because we're multiplying the way that we normally multiply, okay? And we get larger and larger every time. All right, so all of these seem to be, pretty accepted, I hope, okay, in the previous videos. So now we're going to throw in one more concept, which is the concept of rate, okay? Rate is the percent change between outputs, okay? And you can think about it as kind of the complement of factor, because factor is the multiplier that we're keeping, okay? That gives us our next amount and our next amount that we have. The rate is the gain or the loss. So it is the complement, it is the difference of the factor. So let's actually put that in writing first. So think about the factor as the percent we get to keep every time. And that means that the rate is the percent that is gained or lost every time. Okay, so again, it's a complement here. Okay, so let's look at an example. If you've done the calculations and you're told that you have a factor of 1.2, okay? If I were to convert that to a percentage, that means, and we'll talk about percentages if you're not quite sure how to convert back and forth, but we multiply it by 100 if we want to convert a decimal to a percent. So we move, or that's the equivalent of moving the decimal over 2 places. So this is the same thing as 120%. That means every time we keep 120%. I don't want to know how much we keep. I just want to know what the gain is. So what we do is we take 120 and we say, okay, well, 120 is the original 100% that I had, plus it's another 20%. And so this part is the gain. And so I can say that the rate is only the 20% because that is the increase, okay? The fact that this is positive means that it's an increase of 20%. But if you want to say increase, that's okay too, okay? So that means we have a 20% increase or growth, okay? Depending on what language you want to use. All right, for those of you that aren't sure where we got from 1.2 to 120, let's do a little mini crash course in percents. If you pull apart the word percent into two parts, we have per, which is another way to say out of, and then we have cent, which is the Latin root for 100. That's why 1 cent is 100th of a dollar, okay? So this literally means out of 100 when you're talking about a percent. So for example, if someone told you you had 90%, that literally means 90 out of 100. And if you were to convert that to a decimal, which again is just in your calculator, 90 divided by 100, you would get 0.9, okay? So what's the relationship? How can I get from percent to decimal straight away without having to go to the fraction? All that happened here is that I moved the decimal 2 places. So to get from a percent to a decimal, I moved the decimal back or to the left 2 places. If I want to move the opposite direction, if I want to go from a decimal to a percent, then I would move to the right 2 places. Remember that decimals are always out of 1 and percents are always out of 100. That'll help you decide which way you have to move because decimals should always be tiny. They're out of 1, whereas percents, they're out of 100, okay? So they should always be larger. So that gives you an indication of which way you're supposed to move the decimal. Another important fact about percents is the word of. Let's say I wanted to do a calculation of 5% of 60, okay? Of is really just another word for multiplication or times, okay? So I want 5% times 60, okay? But I can't work with percents because percent is a unit. Percent means out of 100. So I need to fix this first. If I fix 5%, I'm going to move the decimal, which is here right now, back 2 places. And this means I want 0.05 times 60. And that will give me an answer of 3. And I can put that directly into my calculator. Okay, so don't worry about the calculation piece. Okay, but this is how we're working with percents. Okay, literally means out of 100, and you're either multiplying by 100 or you're dividing by 100, depending on which way you're converting. Okay, why is this so important? Well, we just saw in this example, if I have a factor of 1.2, which we know should have been growth because the factor is greater than 1, okay, I just look at the difference between 100%, and that gave me my rate of growth. So the amount that I was increasing was the 20%. Now let's take a look at this 0.9, okay? Let's say that we figured out we had a factor of 0.9. So we have a factor of 0.9, and we're being asked to find the rate. If the factor is 0.9, and I converted this to a percent, this means that I am keeping 90% every time. So every increase of 1 in the input, I keep 90%. Okay? But rate is not about what I keep. Rate is what I'm gaining or losing. If I'm only keeping 90%, then that translates to me losing 10%. Because everything's relative to 100. 100% is always your whole. It's always the full amount. So if I kept 90, I means I lost 10. A loss of 10% is shown with a negative. So this tells me my rate would be a negative 10%. I'm purposely staying away from a formula because I want you to get the intuition of the difference between factor and rate, okay? I want you to really think about what that would mean in terms of keeping versus losing or gaining. I do know, though, that some of you want to have that concrete formula, okay? How do you actually calculate rate, okay? Give me a way to do it. And so rate is always going to be your factor times 100, because you're converting it to a percent, okay? Always taking away 100%, okay? Why are you always taking away the 100%? Because the 100% is what you started with, okay? You don't want to count that. You always have to take away the original amount to figure out either the gain or the loss, because you want the difference. This is one way to go. A lot of students like it because they're dealing with 100%. It's easy to view in their minds. But if you don't want to work with percents, you can talk about factor as a decimal, -1, and then multiply by 100. So you're converting to a percent at the end. Same thing though. Why is it -1? Because I don't want what I started with. Okay, so I take away the original amount, okay, and then that's only going to be my difference, my gain or my loss, and then I convert it to a percent. These are the same thing. It's just a matter of when do you want to convert to a percent, okay? Again, a lot of students like this because conceptually you are taking away the whole, okay? You're taking away the original 100%, all right? So this is very important because a lot of times you're going to hear things in real life as a percent change rather than as a multiplier or a factor. For example, we can talk about coronavirus. At the beginning, coronavirus was had an infection rate of 40%. So that means that every time you went out there, okay, the multiplier was 1.4 because you were getting 40% more people infected every time. So that's more of a realistic way that people do talk about exponentials as percentages. So what we're going to do next is we're going to put all of this together, looking at the formulas and picking out the important information. So we're going to make a little chart here, and we're going to look at an equation. We're going to decide if it represents growth or decay. We're going to state the factor. We're going to state the y-intercept. And we're going to state the rate now that we know what the rate means. Okay, can we figure out that percent of growth or decay? So let's do f of x equals 4 times 0.95 to the x. Is this growth or decay? Remember, that's determined by the size of the factor. The factor is 0.95. So we could actually answer that first. Okay. If the factor is 0.95, is this larger than 1 or is it between 0 and 1? This is a decimal. So I know that I have decay, okay, because my factor is a decimal. My y-intercept is the a value here. So 0, 4. You always have to write it as an ordered pair. And now the rate, the new thing that we just learned, this 0.95 means every time I'm keeping 95%. If I keep 95%, that means I am losing 5%, okay? Or you could say there's a 5% loss. It doesn't matter to me which way you say it, but you have to choose one. You can't say a loss of -5 because then that's a double negative. Okay, so you have to pick one. All right, next example. F of x equals 3 times 9 to the x. Does this represent growth or decay? Look at that factor. The factor is 9. That is a very large number. It means it's a large multiplier, which tells me it's growth, larger than 1. What is the y-intercept? The y-intercept is the a value here, so 0, 3. Okay, now here's our new piece, the rate. This means that I have 900% of my original amount every time. So I take away the original 100%, and that means that I have an 800% growth every time. This is growing by 800% because I'm doing 9 or 900%, take away 1 or 100%, and that's what's giving me my 800%. Okay, because again, I don't want to count that original 100. That's why I'm taking that piece away. Let's look at f of x equals 0.01 to the x. This one's tricky. Is this growth or decay? Well, 0.01 is in place of the factor here, okay? So I can fill that in. 0.01 is my factor. That is a decimal, which tells me this is decay. The y-intercept, there's nothing written here, okay? A lot of people would say, oh, well, then it's 0. But it can't be 0 because 0 times anything would be 0. That would make this whole thing disappear. So it can't be 0. But what are we allowed to multiply anything by? We can always multiply by 1, and that doesn't change its value. So the y-intercept here, if there's nothing there, you can always put that imaginary 1 in. And that tells me that the y-intercept will be 0, 1. Another reason that you should know that the y-intercept won't be 0, 0 is because we had said earlier that there is no x-intercept. It doesn't cross the x-axis. So it's never going to be 0, 0 because then that would be through the origin and it would touch the x-axis. Okay, so pay attention to that. Last but not least, we have to figure out what the percent change is, what the rate is. This factor of 0.01 means every time I'm only keeping 1%. If I were to change this to a percentage, it would be 1%. If I only keep 1% every time, that means I am losing 99% every time. Or if you prefer, you can say a 99% loss. But again, don't say both. Okay, you got to pick one. Okay. So let's do a quick summary of what we saw here in terms of our factor versus our rate. Okay. When the factor is greater than 1, we have growth. That corresponds to the rate is positive because it's a gain. So growth and a gain, so the rate will be positive. When the factor is between 0 and 1, or when it's a fraction or a decimal, we know that we have decay that means that the rate is negative because it's a loss. Okay? Something very important to note here. Factor is not negative. Okay? The factor will never be negative. Factor can either be larger than 1 or it can be a decimal. But factor is not negative. The reason why I'm writing that flat out is because that's another common mistake. Okay? Factor can't be negative here. The only time it turns into a negative is if you're talking about the gain or loss, which is when you convert to a rate. Okay? So that's something to just be aware of. Before we get into a few more examples, let's do a little bit more practice with percent versus factor, or rate versus factor. Let's do some fill in the blanks. 3% more than 85 is the same as what percent of 85? So fill in the blank. So 3% more than 85 is the same as what percent of 85? This is indicating a gain, which means we've added it on to 100%. So this would be the same as 103% of 85. Okay, just getting you to think about the difference between what the change is versus what you are keeping. So that means we now have 103% of the total. 12% less than 450 is the same as what percent of 450? 12% less than. This is indicating a loss. Well, if we're losing 12%, what do we keep? Okay, take it away from 100. That means that we're keeping 88% of 450. Okay, always a difference of 100%. 0.03% less than 100 is the same as what percent of 100? This one's tricky because it's a fraction of a percent, very, very tiny. If it's 0.03% less, which means it's a loss, if I take this away from 100%, then that's 99.97% of 100. Okay? These two numbers have to add up to 100%. Last but not least, what percent less than 8,200 is the same as 74.5% of 8,200? This is how much we're keeping. We're keeping 74.5% of 8,200. So what's the change? What are we losing? Again, it's only the difference from 100 always. So if I keep 74.5%, that means I lost 25.5%. Okay, always a difference from 100. So one more time to make sure that we've got this all straight, we're going to fill in one more chart to make sure we've got this. So same thing, we've got an equation, we've got growth or decay, we've got the factor, we've got the y-intercept, and we've got the rate. Let's see how good we are. F of x equals 7 times 1.02 to the x. Okay, you can even pause the video here and see if you can do it on your own, okay, before you see the answers. So, growth or decay, my factor is 1.02. This is greater than 1, so it's growth. The y-intercept is 0.7, taken right out of the formula. And if my factor is 1.02, what is the difference from 100%? That is a growth rate of 2%. So you can say 2% growth if you prefer. The fact that it's positive will also tell you growth. F of x equals 0.05 to the x. Is this growth or decay? Well, the factor is 0.05. It's decimal, which tells me that this is decay. Y-intercept, this is one of the tricky ones. There's nothing written here, but that doesn't mean it's 0. Remember, there's that imaginary 1. That doesn't change the value. So the y-intercept will be 0, 1. Now the rate. If I'm keeping 5%, because that's what this would be if I converted to a percent, then I am losing 95%. Okay, or in other words, 95% loss. Last but not least, f of x equals 5 times 2 to the x. My factor is a 2, which tells me that it's growth because it's larger than 1. The y-intercept, I spot right here. It's always my a value, 0, a. And now the factor is 2, which means if I converted to a percent, 200%. I don't want to count the original 100 though. It's always a difference of 100%. That means that I'm growing 100% every time, or it's a 100% gain. This is an important thing to note just in general in real life. Doubling something is always the same as having 100% more. Okay, so that's always going to be the same thing. So I hope this made sense. Okay, now we got into the concept of rate. And I will see you in the next video.